Hello and welcome to next episode of our top-down game tutorial, and today we have just single topic, and that's enemy attack. After this episode, the enemy will be able to attack us and we will see the health bar above our main character. At first we will create flipbooks for the attack animation, so if you already know how to do that you can skip this part. We will open our sprites folder and search for the attack to get the attack images, and for each of them we will right click and hit the sprite actions and extract sprites. And here again we will choose the grid mode and use the cell with 48 pixels, and we can change the name so we can orient better in the resulting sprites. We have done all of that a lot in the previous episodes, so I will just fast forward here. Once we have all the sprites extracted, we have to select 8 of them for single direction, right click and select the create flipbook and name the flipbook as FB skeleton attack and the direction, for example down. And we will again repeat it for all the sprites, so I will fast forward to make it faster. In the end, we should have 4 animations in the skeleton folder. Now we have to open the animation source skeleton and add a new animation sequence there. So click the add new button, add new animation sequence, and we will name this animation sequence as attack. And as we did before, we have to select the multi-directional sequence, and for each direction we have to set the flipbook matching that direction. I will again fast forward these steps. Then we have to open the animation blueprint for skeleton, because we have to set when the attack animation will be played. So look for the anim graph and locomotion, and here we will add new animation state. And we will also add new jump node so we can jump to this animation state, and the jump node will be named attack. We can then rename the animation state to attack state. There will be 2 transitions, one from the attack to attack state, so we can actually start the attack, and the second one from the attack state to idle, because we will go to the idle state after the attack is over. We can open the attack to idle transition, and we want to switch to the idle once the attack animation is over. We have already done that in the animation blueprint for our hero, so let's open the animation blueprint for hero and copy paste the code from that. We will open the locomotion and attack state to idle transition and simply copy this code from this transition to our animation blueprint skeleton. And we also have to connect the greater than result to can enter transition output. This code gets the percentage of animation played, and if the progress is bigger than 95%, it will switch to the idle state. Now we can open the attack state, and here we have to play the attack animation. So we can again open the attack state for our main character and copy the set directionality so the animation is facing the right direction, connect it to the output and add the play attack action, and connect it to the animation set directionality. We also have to disable the loop animation, otherwise the animation will be played repeatedly, which is not what we want. So now we have to switch the animation to attack from somewhere, and the best place for that is our base enemy class. So let's open the base enemy class and we will create new function here called attack. In this function, we just want to jump to the attack state in the locomotion in the animation blueprint. So let's get the papers at the animation and call its getAnim instance. And from the getAnim instance, we will use the jump to node action. We will connect the white line, so the jump to node action is called from the attack. And we will set the jump name to attack, which is the name of the jump node in our locomotion state machine. And that's all we have to do here. Now we have to call this attack action from the behavior tree for our skeleton. So let's open the AI folder and the BT enemy. Here we will create new tasks, so let's click on the new task and search for the blueprint base. And go to the tasks folder and we will create new blueprint task called attack. As before, we have to override the receive execute AI function. In this function, we want to call the attack function of the base enemy. So let's use the control pawn and cast it to the base enemy. And from this cast, we will use the SBC base enemy and call its attack function, which is our function we have just created before. And that's all here. We just have to create the finish execute and click on the success to make it true. Now we have to click the compile button and hit the Ctrl S to save this task. Now switch back to the BT enemy tree, and from the attack sequence we will just create the attack task. We also have to add the wait task so the animation has a chance to play, and we can also control how often the enemy attacks that way. So draw a new line from the in attack distance and add the wait task, and in the red menu set the wait time to the 0.5 seconds. Now we can try running the game, and if we get close to the enemy it should start attacking us and we should see the attack animation. Now it's time to add the hit detection, and we will do the exactly same process as we did in the video called first enemy and hit detection. We will go to the skeleton anim sequences folder and open the attack sequence. In the attack sequence we will try to find out the frame which the best represents our attack, and we can see it's a frame 6, so right click on the 1 row and add notify and click on the animation notify hit. We have created this animation notifier in the first enemy and hit detection episode, so please refer to it for more details. By adding the animation notifier to frame 6, we ensure that every time this animation is played and there is a frame 6 shown to the player, the animation notifier is executed, and we have a code there which detects all the actors in the hitbox of the skeleton, and the take damage function is called there, so the attack happens. But for the skeleton we actually don't have any hitbox there yet, so we have to create it. To do that, go to the characters and AN hit blueprint, and we will use our draw debug box to see where the hitbox will be. So let's connect the draw debug box again to onReceive notify, and we will also set the duration and thickness to number 2 so the box is visible. We can now go to the animation source skeleton and start playing the attack animation, and we can see that the yellow small box in the middle of the skeleton appears there. This is our hitbox, and now we have to make it bigger and match the sword animation. So let's go to the sprites for the characters and search for the attack 6, which is actually our 6th frame of the attack animation, and open all those sprites. Let's start with skeleton down sprite, and we will add a new socket there. We have to name the socket as hit socket because that's what our animation notifier expects, and we will move the socket to the center of the sword animation. Then we will add another socket there, and this one will be called hit socket size, and it will define how big the hit box is. So we will use the location as explained in that previous episode, and we will start with 10, 10 and 7 as a base number. Now go back to the animation source skeleton and start playing the animation, and you can see that the hitbox appear. And we have to change the number in the skeleton sprite to match the sword animation sword size. So let's increase the number and play with them to find out the right values. Here you can see that the hitbox is too small. The only way how to get the right numbers is really to experiment with that. So after a few tries I found out that the numbers 15, 7 and 14 are the best and match the sword animation. Now we have to do the same for the other directions, so let's go to the up sprite. And again we have to create the socket here, call it hit socket, and move it to the center of the sword animation. We will now create another socket to store the size of the hitbox, and we will call this socket hit socket size, and the numbers will be same as in the down animation, 15, 7 and 14. Note that I mistyped here 13, it should be 14 really. We can now verify that in the animation source skeleton, and we can see that the hitbox looks okay. Now go to the left sprite, and here we will again create a new socket, and we will call it hit socket, and move it to the center of the sword animation again. Then we add another socket to store the hitbox size as a location, and we will call it hit socket size. As an initial value here, as a location, we will use the 15, 13 and 7. Basically, in comparison to down sprite, we will switch the Y and Z coordinates. And if we try to verify that in the animation source skeleton, we can see that it's roughly okay, so I'm happy with this hitbox. Now we can do the same for the right sprite. We will again create new socket and call it hit socket and move it to the center of a sword. And then create another socket and call it hit socket size, and we will use the exactly same numbers as for the left animation, so 15, 13 and 7. Now verify that in the animation source skeleton, and we can again see that it matches the sword animation perfectly. We now don't need the debug box anymore, so in the AN hit let's disconnect it and connect the onReceive notify directly to box overlap actors. Now we have to verify the capsule component in our base enemy class, so let's open the characters folder and the BC base enemy. All the flipbooks in our game must be at the same position in the capsule. If they are not, following issue will happen. Let's imagine we have big capsule with flipbook in the middle and small capsule with a flipbook located at down part. If we create hitbox in the big capsule, it will never reach the small capsule and therefore the attack will not work. So we have to make this capsule smaller and also move the flipbook to the down part of the capsule. While we are here, we also have to check the scale of our skeleton. And we have to multiply the hitbox size by this scale. Otherwise the hitbox would be too small in comparison to the skeleton. So let's go to each sprite for the attack animation and in the hit socket size location multiply each number by 2, which is the scale of our skeleton. So that's all for the base enemy. Now we have to make our main character damageable. So let's open the top-down blueprints folder and there open the top-down character. There we will click on the add button and we will add the damage system component we have created in the previous episodes. Then we will click on the class settings and there we will add new implemented interface and we will add our damageable interface, which should be added to all the objects which are damageable. Once we do that, the take damage interface function will appear in the left menu, so let's open it. And we will drag and drop the damage system component there and call its take damage function. Now we just have to connect all those things together, so let's connect the white lines and also all the variables to the right place. That way we ensure that the following actions will happen. Once the behavior tree runs the attack task, the skeleton animation will be played and on the 6th frame the animation hit notifier will be executed. The notifier will create the hitbox and detect all the other actors in the hitbox using the collision system. Then it will call the take damage function in all the characters in the hitbox, and in our case it will be top-down character, and we will call the take damage from the damage system in the top-down character, which will reduce the health of the character. The next thing to add in the top-down character is the health bar, so let's add the widget component. Let's call the widget component health bar, so we know what widget we are showing there, and on the right menu we will select the widget class and choose the health bar. As we did in the previous episode for the skeleton health bar, we have to make the health bar smaller, so change the draw size to 115 pixels. And we also have to move and rotate the health bar so it's on right direction and it's pointing towards the camera, which is at the top. Now we have to search for the collision and disable the collision for the health bar, so set the collision presets from UI to no collision. And I just noticed the health bar is pointing down instead of up, so let's rotate it back so the gray side is pointing up. Next step is setting this health bar in the damage system component, so the damage system component can update it when there is a health reduction. So let's open the event graph in this top-down character and we will add a new event there called event begin play, where we will set this health bar to the damage system. And we already have a code for that in our base enemy class, so let's close some tabs here and move to the base enemy class and to the event graph. And here we can copy paste all the health bar related code. So let's do it and let's paste it in the top-down character. We now have to connect this to the begin play, and to refresh our memory I will quickly explain what the code does. So the first bar gets the widget component and gets the real widget stored inside this component, which is our health bar, and the second part sets the health bar in the damage system so it can update it later. We can now run the game and let the enemy attack us, and we can see that the health bar appears and it goes down as enemy attacks. The last thing we will do today is reducing the amount of damage done by the skeleton because I don't like how strong it is. Right now we have the hard-coded damage value in the animation notifier hit, and we have to change it to a variable which we can set per each enemy. To do that, we will at first open our iDamageable interface and add new function there. So open the damage system folder and iDamageable interface. In this interface, we will add new function and call it getAttackAmount. This function will have single output, so let's add new output variable, and we will call this output variable amount, and the type will be float, and it will be simply the amount of damage per each attack of the enemy. Hit the compile button and we can go to the next steps. Now we have to open the BC base enemy blueprint and implement this new interface function there. So go to the characters and open the BC base enemy. We will add new variable there called attack amount, and we will change the type to float, and this will be the variable which we will return in the interface. We also have to set it instance editable and expose on spawn so we can edit in the game view. Now we can finally implement that interface. So in the interfaces section, click on the get attack amount, and here we will simply return this attack amount variable. Now we have to do the same thing for our top-down character. So open the top-down blueprints and top-down character, and here we will open the get attack amount function, and we will also add the attack amount variable as we did before, and choose the type to float. And in the right menu, we will set the default value to 25 to match the hard-coded variable we just have in the animation notifier. We must not forget to return this variable in the return node, and now we can go to animation notifier hit, so open the AN hit. And here we will use the get owning actor output, which is actually the character which hits something, and we will use its get attack amount function from that iDamageable interface we have just implemented to get the attack amount and use it instead of the hard-coded 25 value in the take damage. We also must not forget to call this get attack amount from the for each loop. Now we can open the game view, click on the skeleton and search for the attack amount, and change the value from 0 to, for example, 5, and run the game. And we can see that the skeleton attacks with much lower damage, while we can still attack with damage 25. So this is all for this episode. I hope you enjoyed it, and in the next one we will be working on the enemy loot mechanism. So when we kill enemy, we can click on it and drop some items. As usual, please subscribe if you watch this series, it helps me a lot, and see you next time. Bye.